Hello, Professor. This is my submission for assignment 2. The first question linked list, where we create an undo redo interface along with the do method, which creates a list and performs sort and reverse functions on the list. Uh, Moving on to the code, um, we use the doubly linked list code provided and import modules node and doubly linked list. We are creating a new class called myInterface, which inherits from the doubly linked list. As a part of initialization, we super initialize it and set self dot the tail of the node to as the current node. Um, we have a method for count nodes, which returns the number of nodes uh, in the doubly linked list. We have a method to perform the undo action. We have a method to perform the redo action. We have a method to print state, which prints the current state of the list. And we have an init state which returns the initial state of the list. Uh, Coming to the do actions, we first create a list. And so we create a list based on the initial values provided, and we append it to the doubly linked list. And we print after every action we do a print state which shows the current state of the uh, list. The next function is to sort the list. So we are getting the current data, sorting it, and then appending the sorted data back to the doubly linked list. And then we are switching the current element to tail, and we are printing the current state. The next is the reversing the list. Again, we are getting the current data, and we are printing the list in reverse order and then appending the data again to the doubly linked list and setting the current as tail, and we are printing the state here. Adding a new element to the list, we are again fetching the current data, which is the last which is the tail node, and then which is the current node, and then we are appending the new value 9 to the current node, and again we do the again we assign self.current and self.print state. And the next action is to undo back to the reverse list. So we'll have to perform two undo actions. When we do the undo action, it checks if the previous node is not equal to none. If the previous node is not none, then it sets the previous node as the current node and returns. In case if there is no previous node, then it returns undo not possible. So it does twice. Twice does undo and returns the state. I also wrote a redo function, which basically, because we did undo, redo would be possible, and it prints the state. The next action in the question is to add the number 9 again to the current data and print state. And the last action is to undo back to the original state. So to do this, we run the initial state. The initial state method checks if the current node is if there is a previous node to the current node. If not, it sets if there is a previous node, then it sets the previous node as the current node and returns. So when we find once we return out of this method, when we get to the first node, it returns out of the method. When we print the state, it returns the initial state. Now running the code. Here we see that this is the first state when we initialized. Sorting this list, we get the sorted list, and this is reversed again here. We are appending 9 here, and undo back to before you reverse the list. So before I reverse the list, this is the state, and after undo, I see that it's in the same state. and to this state I'm appending 9 again, and then which shows the current state, and then going back to the original state, it reverts to the initial state. Moving on to the second question, stacks. Here we are using the doubly linked list structure to create a class myStack and perform the palindrome option. Here first I'm creating a stack which inherits from the doubly linked list and super initializes similar to the previous question. Created a method push which basically uses the append function as the append function in the doubly linked list and appends the data. So what this function does is it pushes the data into the stack, and SMT checks if the stack returns true if there are no elements in the stack. The next method is pop. It returns the head data or top data in the stack and also removes it from the stack. The next method is assemble word, which have returned to conveniently check the current word and the reversed stack. There is also a method called reverse stack, which basically leverages the reverse method for the doubly linked list and returns the value. To check if a word is a palindrome, we create an object called stack word with myStack, and this S palindrome has the word to be checked as the argument. So we take every character in the word and push it into the stack, and we reverse the stack here using the reverse stack function. And once we reverse the stack, we assemble the word again using the assemble.word method. Now, once we have the reversed word, we are checking if the word is if the initial word is equal to the reversed word. If it is the case, it prints that the word is a palindrome. If it is not, it does not. It prints that the word is not a palindrome. And here is the driver. Here I use with function to open the palindrome.txt file and split it using comma and space so that I get each word. And I run the spalindrome function with word.lower. I put word.lower because capitalized letters and lower letters don't compare with are not same as each other and returns a uh, due to their difference in ASCII value. Therefore, when I do lower, I make sure that we compare like for like cases and returns the correct value. Running the code, we see that morning is not a palindrome, level is a palindrome, madam is a palindrome, first is not a palindrome, and rest of the other words. Moving to the final question about queues used for a remote printing system. A queue is a data structure which operates in FIFO mode. By FIFO, we mean first in, first out. Any element that gets in the queue first is the one that exits the queue first. There is only one entry and there is only one exit. Entry is at the bottom and exit is at the top of the queue. Queue can be a primitive solution for remote printing systems, but there are a lot of issues when a simple queue is implemented for a remote printing system. The first is that a queue will always have only a finite amount of space. So in case where the printer has an issue, like if the printer does not have network connectivity and it's offline, or there is a paper jam with the printer, or if the printer prints slowly, then the then the queue would not be emptied faster, and therefore, if the queue is full, then the no printing request will get in the queue and will be lost. Um, The second reason is that once we send an item into the queue, there is no way to check when what is the status of the request in the queue, because if there is a huge request before the concerned request, then we'll have to wait until that huge request is fulfilled and then it reaches to the current request. One other disadvantage is that it cannot be prioritized. Whatever order the requests are received, it is in that order that the print jobs will be run. So there is no way that if we need to run an important if we need to have a high priority print, we'll have to wait until all the current requests are finished, and then only then will our request be executed. Again, and another disadvantage is that if we put in a request, there is no way to delete the request or modify the request in any way. The only way that we'll be able to do it is to completely clean the queue of all the requests. Uh, that should be all. Thank you.